Dear students, welcome back to the chapter Quadrilaterals. In the previous period, we have seen the family of quadrilaterals and the members in this family. In this period, we will see properties related to one of the member of this family, properties of parallelogram. A theorem: a diagonal of a parallelogram divides it into two congruent triangles, which means we have to show that triangle ABD is congruent to triangle CDB. For that, we can apply many rules, but since they use the word parallel or parallelogram, let us use the property of parallel sides. Because AD is parallel to BC, we can see the Z shape here, so that angle ADB is equal to angle CBD. We have an angle now because alternate interior angles are equal between the sides AD and BC. We know that BD is common between these two triangles, so we can write BD is common. So we have a side now. Again, we can see the next Z shape between ABDC. So angle ABD is equal to angle CDB. This is another angle. Again, the same reason, alternate interior angles are equal between the parallel sides AB and DC. So by ASA, triangle ABD, you know, when you write the congruents, the second triangle should be named carefully. ABD. BD is the last side, so again TB should be the last side. So CDB. Because BD and CBD are the common sides, we have to keep them in the last position. So these two triangles are congruent. What do you understand? In a parallelogram, two triangles are congruent. Moving on to theorem 2. In a parallelogram, opposite sides are equal. So we have just seen that in a parallelogram ABCD, triangle ABD is congruent to triangle CDB. These two are congruent. We have to show opposite sides. What are the opposite sides? AB and CD. Look at the position of AB and CD. They are in the same position. So we can say AB is equal to CD, CPCD. Corresponding parts of congruent triangles are equal if the triangles are congruent. And what are the other two sides? AD and BC. AD first and last letter. BC is also first and last letter. So we can say AD is equal to CB, again CP, CD. So we understand that in a parallelogram, opposite sides are equal. Moving on to theorem 3. If each pair of opposite sides of a quadrilateral are equal, right now we don't know this is parallelogram or not. This is just a quadrilateral with opposite sides are equal. These two sides are equal, these two are equal. Now we have to show that this is a parallelogram. This becomes a parallelogram if PS is parallel to QR and PQ is parallel to SR. So let us take the triangle again, PQS and the triangle RSQ. We know that PS is equal to QR. It's given. So we have a side now. PQ is equal to SR. Again, it is given. So we have another side now, and QS is common. So what do we have now? By SSS, we have these two triangles are congruent. PQS is congruent to starting from P. So here we have to start from RSQ. These two triangles are congruent, which means corresponding parts are equal. That is, angle PSQ is equal to angle RQS. Corresponding parts of congruent triangles are equal. If these two angles are equal, which shows us an alternate interior angle is equal, so these two lines are parallel. Therefore, PS is parallel to QR because alternate interior angles are equal. So if alternate interior angles are equal, you know the sides are parallel. Same way, we can also take the angle PQS also. Angle PQS is equal to RSQ. Again, CPCT. Which means this angle and this angle are equal, which means here this is the Z shape. So PQ is parallel to SR. Therefore, PQ is parallel to SR. And that's what we have to prove. We have to prove that this is a parallelogram. If opposite sides are parallel, then it is a parallelogram. Since both pairs are parallel, that is a parallelogram. PQRS is a parallelogram. Okay, so hope it's clear. So in a quadrilateral, if opposite sides are equal, which means it will be a parallelogram. Moving on to theorem 4. In a parallelogram, opposite angles are equal. We have seen that in a parallelogram, let's name PQRS. We have seen angle 1 is equal to angle 2. Again, angle 3 is equal to angle 4. Because alternate interior angles are equal. Now we can say angle 1 is equal to angle 2 and angle 4 is equal to angle 3, corresponding parts of congruent triangles. Because in a parallelogram, it cuts into congruent triangles. Now when you add these two, we get that 1 plus 4 is equal to 2 plus 3. 1 plus 4 means angle S. Angle S is equal to angle Q. Similarly, when you draw a diagonal from P to R, joining PR, we also get that angle P is equal to angle R, which means opposite angles in a parallelogram are equal. Moving on to theorem 5. If in a quadrilateral, each pair of opposite angles are equal, then it is a parallelogram. Opposite angles are equal. So we are given that the whole angle, let's say this is 110, this is also 110, and here it is, let's say 70 and 70, then it is a parallelogram. It is by construction we can do that, or even by activity we can show that. You will not be asked about the proof for this theorem. Let's move on to theorem 6. The diagonals of a parallelogram bisect each other. For that, let us consider the triangle PTQ and STR. We are given that it is a parallelogram. We have to show QT is equal to TS and PT is equal to TR. So let us take the triangle PTQ and triangle RTS. From these two triangles, we know that PQ is equal to SR because they are the opposite sides of parallelogram. Also, we know that angle QPSQ T is equal to angle SRT. Alternate interior angles, because this is parallel. So we can see a Z shape. Alternate interior angles. For the sides, PQ parallel to SR. Again, we can say that these two angles are equal. Also, angle PQT is equal to angle RST. Again, the same reason. So we have angle side angle by ASA. Those two triangles are congruent. Triangle PTQ is congruent to triangle PTQ is congruent to triangle RTS. The question is to show that PT is equal to TR. PT and TR, they are in the same position. So PT is equal to RT or TR, which means corresponding parts of congruent triangles are equal. Again, we have to show QT is equal to TS, the same. TQ is equal to TS. Corresponding parts of congruent triangles are equal. So we find that diagonals, therefore, diagonals are bisected. Are bisected in a parallelogram. Hope it's clear. Moving on to theorem 6. If the diagonal of a quadrilateral bisect each other, then it is a parallelogram. Bisect each other, which means these two are equal and these two are equal, which means these two triangles are congruent by side angle side. We have proved such situations many times. So these two triangles are congruent, which shows that these two sides are equal. So we get A, B, C, D. So we can find from triangle, or we can directly write triangle AOB is congruent to triangle COD by SAS. Side, angle, side. Okay, so we can see that AB is equal to CD, CPCT. And we also have angle ABO, which is this angle is equal to this angle. Angle ABO is equal to angle CDO by CPCT again. Which means, therefore, we can see the Z shape here. Alternate interior angles are equal, which means AB is parallel to CD. Now we get one pair of opposite angles are one pair of opposite sides are equal and parallel, which means that will be a parallelogram. Therefore, ABCD is a parallelogram. That's all about the theorems. Now let's move on to an example. Show that in a rectangle, all angles are 90 degrees. You know, in a rectangle, opposite sides are parallel. So these two sides are parallel, which means we can apply the same side interior rule, or the C rule. C, not Z, C. So we can say angle, let's name it PQRS. Angle P plus angle Q is equal to 180 degrees because same side interior angles are supplementary. between the sides PS parallel to QR, because in a rectangle opposite sides are parallel. Now, let us take a construction saying that one of the angle is 90 degree. Just by construction, so we can say let angle P is equal to 90 degree by construction. So if P is 90 degree, you know that, let's substitute it here. So 90 degree plus angle Q is equal to 180 degree. So angle Q is also 180 minus 90, which is 90 degree. So we get angle Q is 90 degree. Now we also know that PQ is parallel to SR. So let us say, take this side now. So we will get P and S are 180 degree. So also angle P plus angle S is equal to 180 degree because PQ is parallel to SR. But you know PQ is angle P is 90, so angle S is equal to 90 degree again, since angle P is 90 degree. So we get all the three are 90, here 90, 90, 90. Same way if you take between S and R, again, angle S plus angle R is 180 degree. Why? Because PS is parallel to QR. So, but you know S is 90 degree. So therefore, angle R is equal to 90 degree because angle S is already 90 degree from here. So we have seen that P is 90 degree, Q is 90 degree, S is 90 degree, and R is 90 degree. So each angle in a rectangle is right angle. So how did we start? By taking one of the angle 90 degree. That's all for today. With more example, we will see in the next period. Thank you and see you later.